All right, let's get started. I guess everybody decided to watch the recording. Now, first I'd like to show I do record. So my recording is here. So it's right here. So that's last week's recording. So if you're unable to attend the class in real time, that's actually like I said last time, I asked my daughter and my son about the college experience on Zoom. They actually like the Zoom meetings, and they said they like watch the recordings. They can fast forward. They can watch it at twice the speed, or 1.5 speed, 50% faster, or double the speed. So anyway, that's what today we're going to start our first class, first one. So let me switch my camera. All right. So did you got the book, Austin? Yes?
Just a PDF version of it, but yes, I do.
Perfect, perfect. So today we're going to start at the beginning. So that's chapter 1, Introduction to Electronic Communication. Chapter 1, we have 8 topics. So today, that's what I plan to do. So 8 topics. So this is 8 topics we're going to cover today. First topic is what are we going to cover? What material? Second will be how do we do it? The technology. Third is, again, different types of communication. Then we followed by modulation and the multiplex. There's 2 different subjects. Followed by spectrum, by bandwidth, by examples, and last one, the most important one. Show me the money, right? Jobs and careers in this area. Let's start with first one. What are we going to cover? Actually, it's right here. It says that's what we're going to cover. Communication. Communication. So if you know, if you talk to any people successful, talk to the guys who make millions, what do they tell you? The most important skill is communication, right? You know, that's unfortunately is not our subject. It's all called communication, but our communication will not make you millions. Not that type of communication. That is taught by another department. Another professor, her last name is also John, same last name. She taught communication in the Department of Communication. That kind of communication is most important. Our kind of communication, yeah, it's important. Get you a job. You might get a couple of tens of thousands, like $5,000, 50,000, 70,000. Anyway, our communication is not people-to-people communication. The communication we talk about is a machine-machine communication. We were talking about machines, yeah. So, of course, the machine are operated by people. So, yeah. So the communication, our subject is the machine, which makes human communication possible. So we build machines to make people communicate. And our subject of communication is build machines or studied machines. So that is our first subject. We are studying machines, not make you a better communicator, fortunately. Second topic, how do we build those machines? Well, give you an idea. So this is a transmitter, communication, yeah, transmitter, receiver. So this is the machine we're going to build or study. This big picture. So we will have a sender, we have a media, and then we have a receiver. Oh, that's the system: sender, media, receiver. More accurately, we only study one media, that is RF media. So we're talking about wireless communication. So in this class, we're not talking about fibers. We talk a little bit, but not fibers. Mostly we are studying the radio frequency communication. So you have a sender. We don't call sender. That's not technical. You will not get a job if you interview yourself senders. They will not hire you. They think you don't know. You know nothing. Transmitter, right? We call it transmitter. So transmitters, followed by a receiver. Usually the transmitter and the receiver are built at one box because you not only want to transmit, you also want to receive. So we call it a transceiver, right? Transceiver. It's a transmitter, receiver. We just created one new word called transceiver. So we have a transmitter, we have a media. We call it media, sometimes we'll call it channel. RF channels. And we have a receiver. Now, the reason we build this, the reason we want to study this is because we want long distance communication. So let's move to the third topic. Well, in the old days, if you want a long distance, what do you do? Like 100 years ago, 1,000 years ago. You shout, right? You yell. So that's what's still happening in nature. You see the big mammals. I heard their voice can be heard miles and miles away, right? The whales, the wolves, the dogs, yeah, they all shout pretty loud, right? That's how they long distance. But no matter how loud, the distance is quite limited. So that's why we invented this wireless RF communication system. Let's give you an example, the television station. So right now, I don't have cable in my house. What I did is I put an antenna And I can receive about 20 TV stations from Kansas City, 20 stations. So that's enough. Keep me busy. If I want to watch some TVs, I just watch either YouTube or online, or I just watch from antenna. So Kansas City is 60 miles away. So that's your antenna television station. 60 miles away. 60 miles away. Another communication system we use quite often is the cell phone. That's your cell phone. So you talk to your friends, and your friends heard your voice, and your friends talk back, you hear what. So it's called a full duplex. Full duplex. Types, you have full and half. Full and half duplex. This is called half duplex. Half duplex. Why? Because when you receive television, when you're watching TV, you're only receiving. Your TV is now sending out signals, right? Unfortunately, today's TV are sending out signals. Do you know that? Your TV probably is watching you when you are watching TV at the same time. That's no good, right? That's scary. Your TV is listening to you potentially because your TV is a computer. Today's TV. The old TV, it's a one-way communication. Today's TV is still one way as far as the television station is concerned, but because your television is a computer with a microphone, some TV even have cameras. That means potentially, yes, you are being watched also by maybe, I don't know, who has that technology capability to hack a TV or actually pre-install. Hopefully that TV is anyway, so TV, full duplex and half duplex. And just like everything else, the communication system started with analog, changed to digital. So we started our communication system as analog. It's all analog. So if you go back 30 years or 40 years, it's all analog communication. So those guys have receivers, transmitters, have antennas. Then you can communicate. So analog. Today it's all changed to digital. So those are the different types of communication. We also covered. So analog, today we still use it every day, like FM radio. So now we are talking about another technology, another word called.
Billy, bring me my headset, please.
Huh?
Oh shit.
Oh my.
Sorry. Thought I was muted.
Okay. So when you want to long distance communicate, the first thing you need to do is called modulation. Without modulation, your signal cannot travel too far. So you have to modulate to have your signal travel long distance. So what do we mean modulation? There are three multiple ways to modulate radio signal, multiple radio signal. The first modulation is called AM. So that's AM modulation. And I have here an AM signal I want to show. So let me switch my cameras. Let me switch my cameras. And I can show you the AM signals, what it looks like. So this is an AM signal. So we can change how much we modulate. You see the difference? It's the same AM signal. What's the difference? The amplitude change a lot, right? We can also reduce that. Yeah, that's AM signal. Let's see. AM. And we also can change the frequency. Right now it's 25 hertz. So what do we mean 25 hertz? That means the envelope. This is called envelope. Let's change to, for example, 50 hertz. Now it's 50 hertz, 60 hertz, 70. Now it's 130 hertz. So you see our AM signal the frequency actually changes. Okay, the frequency actually changes. All right, that's AM signal. So right now, the carrier frequency is 1000 hertz. So what do we mean the carrier frequency? The carrier frequency is the high frequency signal. So this is 1000. And we are using 100 to modulate 1000. What does that mean? If I freeze that, that means for every one of those sine, you have 10 of those sines, right? Yeah, you have 10 sines. This has 10 cycles for every one cycle of envelope. We call it envelope. So one envelope, you have 10 carrier cycles, 10 carrier cycles. So the carrier frequency is 1000 hertz, and the actual signal we want to send out, that may be music, that may be, yeah, if you listen to AM station, that will be the signal we send out. This is called AM. The second one is called FM. So let me switch to FM.
وانت بين حطه السلام وفضل سميناهم
All right, now I switch to FM. Did you notice the difference? FM?
بحصل ايه؟ عم توضي عم بدفع اتوضى شايف جسمي شو عندي؟
ايه خطوط الزر موجودين تحتي الدرج التحتي عشان تسعد انا راح اصمم
لا صبر استئذان
ايه ان شاء الله يمين يعني ما كمل الحديث مصاصتين العيال يسكر حلجة عشان لا تحطون شيء حلجة.
Okay, I think everybody hear me, right? I can find the all right, the FM, if you see the FM, notice the amplitude never change, right? The same amplitude. So the envelope is flat. The envelope is flat. But what changes is the frequency. So if I stop it right here, notice the frequency is you see the frequency is lower and higher, lower and higher. If you watch it in real time, it's like this. Yeah. So we have frequencies low, and we can frequency as high. Yeah. So this technology called FM. So our modulating signal will change the frequency of carrier. So in this case, the modulating frequency is 5 Hertz, and the carrier is 1000 Hertz again. Carrier is not changed. Okay, now I see anybody. Oh, I was confused because I didn't see the picture, the webcams. So now the carrier. So anybody see my demo? Did you see the demo? Anybody? I didn't get feedback, but everyone saw the demo, right? Yeah. Okay. Thank you. Thank you.
It, yeah.
Huh?
I saw parts of it.
Part of it?
Yeah.
Okay. All right. That is analog. How about the digital? When we do digital communication, we are sending out zeros and ones. So if you're sending out zeros and ones, it's called FSK. Let me show you FSK. So this is FSK. So what it does is this is alternating in sending zeros and ones. So the high frequency will be 0, the low frequency will be ones. So we got the high frequency and the low frequency, and So yeah, that's better. So part of the signal is a high frequency and part of the signal is low frequency. And so we're alternating between the high frequency and the low frequencies. And when we're alternating, the receiver will receive zeros and ones, take turns. So 1 0 followed by 1, and then followed by 0 followed by 1. What happens if you are playing music? Obviously, that will be not all 1 zeros or followed by ones. So you might have a couple of 0 followed a couple of 1, multiple 0, multiple 1s, and that's how you send out your digital signal. This is the very basic. Your cell phone is much more complicated. Right now is 5G or 4G is much complicated than this FSK. But FSK is a good start. So you always use this FSK to transmit your digital binary signals. So that's FSK. So that's our first couple of topics. The second topic will be multiplexing. So topic number 4, we have 2 topics. The first topic is modulation, 3 modulations, AM, FM, and FSK. So 1.4.1, we have AM, FM, and FSK. The second topic, this is called modulation. The second topic is multiplex. What do we mean multiplex? Multiplex means we use one carrier to transmit multiple signals. So in this, for example, FM, you have one music, and to a receiver, you have one speaker, right? That is one signal. What about you have multiple signals, and you want to send out through the same, you have 1, 2, 3, 4, 5 signals. 5 signals, and you want to send out through this transmitter, and the receiver, you have 5 different speakers. This is called multiplex, MUX. So you combine multiple signals, and you send it out through one carrier, multiplex. And on the receiver side, it's called a DMUX. Demultiplex. That means you will separate the 5 and send it out to the right speaker. So 1 will go speaker 1, 2, 3, 4, 5. And so you mux them together, multiplex them together, and on the receiver side, you will separate them. And so that's the idea of multiplex. Another example of multiplex is, for example, you call your friend, cell phone. Multiple people can make the phone calls through a single cell tower. So you have only one cell tower, one antenna, but dozens of people can make the phone calls at the same time. So if too many people want to make a phone call, sooner or later you run out of channel. So this is a multiplex, means this is a 5-channel multiplexing. So you have 5 people can make the phone calls at the same time. In typical cell tower, it's a number of 64, multiples of 64. So if you have 64 people making the phone calls using cell phone, call your friend at the same time, nobody else can add unless you add another antenna. So you can have a so multiplex is a good idea. How to do it? There are many different ways. Multiplex is such an important topic. People does spend millions, and so many smart people research how to more efficiently use the same channel. That is why in our cell phone system, we have 2G, 1G, 2G, 3G, 4G, and 5G. What's the difference between all those Gs? One big difference is more advanced multiplexing technology. More advanced. That means more people or faster downloads, right? Because more channel, we want more channel. More channel means faster internet speed, everything, faster everything. So multiplex is a huge subject in communication. There are many ways to do multiplex. TDM, FDM, CDM, and goes on forever. So there are many different ways to do multiplex. The author do not cover this subject. The author only have a half page on multiplexing. So basically you have multiple signals and you have multiple outputs, and you want to combine them when you send it out, and then when you receive it, you want to separate them. You do not want to have some crosstalk. I call crosstalk. That means the signal 1 will ended up on the channel 2. That is not good. So multiplexing means separate them, differentiate them 100%. So there are the 3 technologies, 3 multiplexing technology. The first one is called time. Second is called frequency. Third one is called code. Time and frequency is easy. Time, what is the time division multiplex? Everybody take turns to talk. Everybody take turns to talk. So right now we have 6 people in this Zoom meeting. I will talk for 1 minute, and then followed by Tim, followed by Chura, followed by Annie, Jeremy, and Austin. So everybody talk 1 minute. That's time division multiplexing. So we use the same Zoom meeting channel, and everybody can talk 1 minute. Well, that is no good because you want the same time. So for me to talk again, I have to wait five minutes, right? Yeah, I don't want to wait 5 minutes. Nobody, when you're using your cell phone, you don't want to wait 5 minutes, and then you talk 1 minute, wait 5 minutes. So this time division multiplex is actually everybody talk for 1 millisecond. How does that work? I talk 1 millisecond. What is 1 millisecond? 1,000th of a second, right? 1,000th of a second. In computers, it's even shorter, 1 microsecond. So everybody talk 1 millisecond. We are talking about computers. We're not talking about people. So TDM is how computer share one channel. That is actually how Wi-Fi. We are using Wi-Fi. I see a lot of people using Wi-Fi right now. I'm guessing this is how Wi-Fi works. Wi-Fi can connect, for example, dozens of computers. Each computer talks 1 millisecond. So the first 1 millisecond, I will talk. Let's assume all 6 of us are computers. I talk 1 millisecond, and then Tim is another computer, talk 1 millisecond. How fast does a computer talk? What can computer talk 1 millisecond? A lot, right? For us, 1 millisecond is unbelievably short. For computers, 1 millisecond is huge, huge. So that's how computers share one channel. What is FDM? FDM is a frequency domain. Again, we talk, but I talk at lower frequencies. You talk at higher frequencies. So that's how people talk, or computer, or machines talk. A good example is what is a good example of FDM? Is the stereo broadcast. Stereo broadcast. So in stereo broadcast, you have 2 channels, left speaker and right speaker. How can you transmit left speaker and right speaker 2 sound channels using the same carrier? What it does is it do FDM. So one speaker will have a higher frequency ultrasound. One speaker will use ultrasound. Another speaker will use ordinary sound. When the receiver received it, the ultrasound one will be converted to normal sound, send it to the second speaker. So you first convert one of the music channel into ultrasound, and then you combine together, send it out. When the receiver received, it will receive one channel, but the other channel is ultrasound. Nobody can hear ultrasound. So your receiver will convert it back to normal sound and send it to another speaker. So that is called FDM. What is the last technology? CDM. CDM means code. C, the first letter C means code. It's a code division multiplexing. I always use this analogy. For example, we have 6 people here. I will talk to Austin using English. So I will speak English, Austin will speak English. So we talk. Jermaine and Tim, what do you speak? You speak Spanish? Okay, yeah. Tim speaks Spanish? No? Pretending you do. Pretending you do speak Spanish. So you two will speak Spanish. I and Austin speak English. Hani and Arturo will speak Chinese, okay? So we all talk at the same time. Does it work? Yes, it works. It works. I will talk English. I only understand English. Austin only understand English, and we only listen to English. Our ear is tuned to decoding English, and we talk English. And then Tim and Jeremy is talking Spanish because that's the only language you know, right? You don't know English. So your ear, your brain is tuned to only listen to English, no, Spanish. So that's code division multiplexing. Everybody talks with a different type of code. It's kind of crazy, but it works actually. So that's the multiplexing and demultiplexing. So on the receiver side, you need a demultiplexing. On the transmitter side, you mux them together. Any questions? I kind of stop a little bit. We already half finished. So we already covered 4 topics. 4 topics. I covered draw a line. So half done. No questions? No? Let's continue. The next topic is the topic of spectrum. The RF frequency spectrum. The RF frequency. This is all the frequencies of a radio signal started from low frequencies, very low frequencies, medium, high frequencies, very high, ultra high, all the way to microwave, right here, microwave right here. And if you notice here, you have a millimeter wave. What are we talking about? Millimeter. We are talking about the lambdas, the wavelengths. So this is lambda. This is lambda. So what is this? This is the speed of RF. So speed of RF is that's how fast the speed of RF travels. Is that right? I hope I'm right. 3 times 10 to the power 8 meters per second. That's how fast light travels. And if my frequency is maybe 6. Is 6 or 8? Anybody can correct me? Let's say 6. All right. If my frequency, what is the frequency you listen to most often? 100. Oh, it's 8. It's 8 megahertz. So if you are listening to 100 megahertz, that's a FM station. The one I listen to most often is 89.3 megahertz. So that's the station I listen quite often, 83 megahertz. So what will be the lambda? So I will do 300, right? Divided by 89.3. The lambda is 3.4 meter. 3.4 meter. That's called wavelength. So the wavelength of this station is 3.4 meter wavelength. It's like if you imagine, you can visualize the radio signal as the water. If you go kayak or boating, when you see water, you have waves, right? What the wavelength means the distance between two waves. The distance between two waves. And in that case, the RF signal, the distance between the two waves is 3.4 meters long. It's I'm 1.8 meter, so it's twice as much as so two people's length. So that's how far the waves are separated in RF. What is a millimeter? Millimeter means the wave is separated only by a millimeter. If the wave is only separated by a millimeter, that means the frequency is in tens of gigahertz. So this is a tens of gigahertz. So the frequency is much higher. It's not megahertz. It's not 89. Now it's like 89.3 gigahertz. 89.3 gigahertz. And then you're talking about 3.4 millimeters. So yeah, 89.3 megahertz. Lambda is a 3.4 meter. If it's 89.3 gigahertz, the lambda will be 3.4 millimeter. That's what we are talking about. We're talking about dozens of gigahertz. So millimeter. Why we talk about millimeter? Because that's one of the frequencies 5G cell phone is using 5G. So this shows all the potential carrier frequencies. So which one is the best? Well, there's no best. They all have advantages and disadvantages. For example, the 5G use this millimeter. What is the advantage of millimeter? What is the advantage of millimeter frequency? This frequency right here. 5G. Faster, right? That's huge advantage. Faster. So I was told I never use 5G. I was told you can download a movie in minutes, 2 minutes. 2 minutes you download a complete movie. That fast, right? Anybody have 5G? No? Nobody has 5G? Okay. We need to do a research project. Ask your parents, 5G, we're taking a class.
How about 5G Wi-Fi?
Oh, 5G Wi-Fi, that's 5 gigahertz. That's 5G, not the same 5G. This is what I'm talking about, 5th generation.
Yeah, no.
Fifth generation. 5G Wi-Fi is a 5 gigahertz Wi-Fi. 5 gigahertz Wi-Fi. And I'm talking about the carrier frequencies. All right. That's a good research project. 5G cell phone. So each has advantages. What is the disadvantage of this frequency? Millimeter. Disadvantage is it only travels at the line of sight. It only travels short distance. So for 5G to work, millimeter wave to work, you have to have a lot more antennas. Fortunately, each antenna is a small size. It's like a suitcase. So you can put a lot of those. For example, in Shenzhou, 4G, for example, 100 antenna is enough. But if you deploy 5G millimeter, you may need 1,000 antenna around Shenzhou to make it work, because they don't travel a mile or half mile as 4G. They only travel maybe 100 to 200 yards. So you have to have one every 200 or 300 yards. You have to put more density, more antenna. What about the advantage of here? For example, I have 300K. 300K. What is the advantage of 300K carrier, RF? Long distance. How long? Potentially, you can across the world. So basically, you can talk to people in Europe, Africa, with this type of radio. So it's a longer distance. So each has advantages and disadvantages. And right now, they are all taken. This is like the real estate plots. It's very expensive real estate. This part is like the most valuable. It's like the oceanfront properties. So they cost billions of dollars. And the others maybe a little bit cheaper. So every square inch, not square inch, every spectrum, every frequency is taken. Who decide who get which part? Who make a decision? Every country makes their own decisions. Yeah, government, every country. Usually they follow international standard. So for example, the TVs in Asia use the same frequency that TVs in America. So they follow some standard. But each country can decide which frequency to, which agency owns or occupy which frequency. So that's our fifth topic. So the frequencies, the RF frequency, the radio frequencies can go, current technology can go up to 300G. That's extremely high frequency. As low as hertz, hundreds of thousands of hertz. Now, if you continue looking at the spectrum, if you noticed, this part of the radio became light. That's current understanding is light is also electromagnetic wave. So the only difference between light and RF is the frequency. So if your frequency goes higher, continue go to very high, and it became light or X-rays if you continue go higher and higher. So that's our fifth topic. The next topic talk about the bandwidth. So basically, when you using radio, you have a upper and the lower frequency. Upper and lower frequency. For example, if I'm listening to 89.3 megahertz, it's 100K below, 100K above. So the carrier frequency is right in the center. The center is 89.3. So what will be the upper frequency? 89.4. What will be the lower limit? 89.2 megahertz. So when we talk about the 89.3, we are talking about the center frequency. But actually, that station owns 89.2 to 89.4 megahertz. What about the frequency above 0.4 to 89.6? That will be a different station. So you have station 1, you have station 2. Station 1. So when you listen to FM radios, when you tune to the first station, you're listening 89.3, and you listen to second station, what is the carrier? 89.5. 89.5. So that will be the second station. This will be, for example, news. This will be music. So you can switch stations, right? So what is the idea of bandwidth? Bandwidth. This is called bandwidth. Bandwidth is 200K hertz in this application. 200K hertz. So that's your bandwidth. This is the bandwidth for FM stations. How about AM station? What is the bandwidth when you listen to AM? 20K. So the AM station is much closer to each other. The bandwidth for each AM station is only 20K. That explains why AM is only used for talk shows, right? FM is used for music. Because when we listen to music, we want to listen to more clarity, high fidelity. In order to transmit all the details of the music, we need that bandwidth. For AM stations, we're only interested in talk shows. We only want to make ourselves understandable, like in this Zoom meeting. So each station will have much narrow bandwidth. So bandwidth basically means the size of your lot, right? So if you're poor, you buy a tiny lot, right? Build a tiny house. The rich guys, you have millions, they can buy 20 acres, right? That's the difference. Yeah, so this is similar. So you have a bigger size bandwidth or small bandwidth. Generally, the bandwidth is determined by your requirement, how much you want to communicate, how much information you want to send out, and how much information you want to receive. And all right. Is everybody still see the sharing of my? Let me see, my sharing. The sharing works? Do you see my sharing? Okay, okay, thank you. Because my computer freezes for All right. That's our topic number 6. Bandwidth. Check. So we have last 2 topics before we're done. 10 more minutes. Don't fall asleep. 10 more minutes, we're done. So next topic is examples. So we will give a couple of examples of communication. The author gave a lot of examples. So let's read a couple. Example number 1, AM/FM radio. Example number 2, digital radio, like satellite. TV broadcast. Yeah, we watch TVs using antenna. Digital TV broadcast. Yeah. Cable television. Cable television is modulated also. So you have one single cable. How many channels you have? I don't have cable. If any of you have cable, right? How many channels do you have? 100? $200? Okay. So then you have fax, wireless, remote, Internet of Things. Internet of Things, basically a small computer, inexpensive, control some devices. So your house can be controlled online. Internet of Things. Navigation, GPS. GPS is a perfect example of one-way communication. So your GPS unit is only receiving your GPS signals. The GPS signals from satellite, and you're receiving them on your receiver. Let's go back to a couple of examples of two-way communication. The first two-way communication is telephone. Telephone is the oldest type of two-way communication. Two-way radios, that's very popular. If you have a two-way radio, walkie-talkies, right? Yeah, you can talk. For example, you're hiking with your friends, your buddy, you can talk to each other. Radar is a two-way communication. Yeah. Sonar, underwater sonar. Sonar is a two-way communication. Yes, radar and sonar is two-way because you transmit, you have to listen. That's two-way. Amateur radio. Anybody use amateur radio? Anybody heard of amateur radio? Nobody heard of amateur radio? It's a generation thing. Yeah, if you ask your father, older, especially, how do I say it? Yeah, the older generation. The amateur radio is huge. Basically, you put an antenna in your backyard. You have a radio. You can talk to people hundreds, even thousands of miles away. Amateur radio, two-way. You can talk two-way. I heard people talk to people thousands of miles away, like in Asia, Europe, before the internet. This is huge because now we have internet. If you meet a person from Africa, you say, nah, that's no big deal. Anytime I want to talk to people from Europe, I can go Facebook, right? You can chat with people anywhere in the world. Today it's not big, but 50 years ago, when you all of a sudden you're talking to someone in Africa, real time in your basement, how exciting is that, right? So this is amateur radio. It's a long distance radio, amateur, so everybody can use. In United States, every country has different laws. In the United States, you have to be a citizen. I'm not sure the current law, but the old law says you have to be a citizen to use amateur radio. Citizen radio. Anybody hear that? Citizen radio? CB radio. Anybody use CB? That's the truckers. When the truckers want to talk to each other, they use CB radio. I have one very old one in my basement. I have a couple actually in my basement. Many years ago, I put one in my car. So I'm driving, I'm really bored. I tuned and listened the truckers talk. You can also talk, but you can listen and talk at the same time. This is about 10 watts. 10 watts. That translates to maybe 20 miles or 10 miles range. So the CB radio, the truck drivers use them most often. They can talk to each other up to 10 miles. If you put more power, maybe 30 miles, 60 miles. So it's a nice way to communicate with each other. CB radio. Family radio, those are the baby monitors, right? The kind of thing you use, the baby monitors. So there's a lot of those. The last topic, move to the last topic. We're almost done. Last topic is job and careers. It's an excellent job and a career opportunity. I always say, for university education, picking the right major is more important than picking different schools. So you can go to a very good school. If your major is no good, chances are your potential job, the career opportunity is limited. But if your major is in one of those in high demand, then you have huge opportunities. So communication is one of those. In the past dozens of years, a lot of job opportunities, especially in Kansas City. I used to live in Kansas City. Almost all my friends, I have to say almost all my friends, works in Sprint. Majority of my friends. So that's the biggest employer. They hire 30,000. I'm not sure right now, but when I was in Kansas City, I moved out of Kansas City 10 years ago. But 10 years ago, it's 30,000 employees. Everybody works for them, and huge amount of opportunities. They have RF engineer. What kind of jobs what kind of people they hire? Basically, if you RF, they have hire RF engineer. This is this class, RF engineer. Those people drive around the city, trying to figure out the coverage of their signal, right? RF engineer. And then, so you have the component manufacturers. Sprint is not a manufacturer. Sprint doesn't make anything. They don't make a cell phone. They don't make equipment. They are a service provider. So they just buy this equipment and provide the service to the end customer. So a lot of job opportunities. Database, software. So a lot of computer jobs because everything is computer. So that's actually majority of people do. They like slaves work on computers 8 hours a day. It's a tough job, computer job. But usually you don't have to work 8 hours. The thing for working on computers is all you need to do is stare at your screen. That means you are working, right? Stare at the screen for 8 hours. Okay, that's pretty much all we want to cover for chapter 1. It took us about 17 minutes. We did it without a break. So if you, we don't have homework, again, it's all reading. Read chapter 1. I will put some quizzes next week or this week. I haven't decided on the time schedule. If I put the quizzes on there, usually it will be due a week later. So if I put it on Monday, I was expecting to grade it and put it on your grade book next Monday. So a week due date. And the labs, okay, Dr. Zhu teach labs, so I'm not teaching labs here, but I'm not sure about the lab. But hopefully the labs will keep tracking the instruction, and I will do as much demo as I could to make it more lab-like or more easier to understand. Okay. Thank you, everybody. Any questions? Otherwise, I will see you next week.
Yeah. Will the quizzes is that on Canvas?
Yes.
Okay.
Excellent question. The quizzes, I will post it. I will send you out the email. Yeah. Everything is on Canvas.
Okay.
So it's pretty much required. So if you don't have.
Right. Okay. Thank you.
So you're still in Ohio, Truro?
No, I got back on Friday night. I just had a rough morning this morning, and I didn't get any sleep, so I slept through pretty late. And yeah, no, it was. I got back from Ohio Friday. Had to work the weekend, and yeah, it was a good time.
That's good. I didn't see you sleeping, so I don't know.
Well, the 11 o'clock class, I don't remember who teaches that, if that's you or somebody else, but I missed that one.
That means you're sleeping pretty good. You don't even know the instructor. All right. I will see you guys next week. I recorded everything, so hopefully, oh my God, did I record it? I hope I pushed the record button at the beginning. Yeah, I'm recording it. Yeah. So I will post it, and you can watch the recording. All right. See you guys later.
Alrighty.